before, and that is our identity slash dependent. So dependent says the solution set is every real number for which both sides are defined. We already called that dependent, but I'm also going to call it an identity in this section. It will look something like, let's say I have 2x plus 1 equals 2x plus 1. We're going to notice both sides look the exact same. So no matter what I plug in the left side, as long as I plug in that same thing on this side, you're going to get the same result. Our answer is going to be dependent. It's an infinite set of values that we plug in. Now, as a reminder, if you didn't realize that they were equal on both sides, you may actually solve it using like subtracting both sides, moving our x's together and stuff. And you might end up with something that looks like 1 equals 1. So when solving it, if it comes out to a true statement, we've seen that before, that is our dependent or our identity. So you might either see that it's equal or you might get to that. Conditional. Conditional is one that is satisfied by at least one solution. So a dependent is considered a conditional. But most of the time when we list conditional, it means like we just have a couple solutions or one solution. So an example of that might be 2x plus 1 equals, let's pick something that works, let's go 7. Not an identity. So that means you would keep working through this and you'd end up with just x equals, what would that be, 3. That means you have a conditional. It's just one solution. Definitely not dependent, so we just put conditional as the highest ranking thing that we can. The last thing we talk about is inconsistent. Those we'll just put no solution, inconsistent. You can put a circle with a line through it. You can put braces that are empty. That's called the empty set. You can also put braces with that circle with the dash through it. That also stands for empty set. As weird as it seems, these two things are slightly different if you get into set builder stuff. But for our case, they'll both be the same. All values will make the statement false. So an example of that might be, let's say I have x plus 1, and that has to equal x. Well, adding 1 to a number and making it equal that original number doesn't work. I'm shifting something right 1. It can't be where it started from. If you were to solve this one by subtracting x on both sides, you'd realize that that's going to just be a false statement. If we come up with a false statement, we are then inconsistent. In this lesson, we're going to come up with something else for inconsistent. As a quick reminder, you can never divide anything by 0. So in this lesson, we're going to have lots of fractions. That's going to be the hard things to solve when solving for a variable is when you have lots of fractions in it. Well, if you ever have a fraction with a variable in the bottom, you have to make sure that variable never turns to 0. So in fact, as soon as you start doing a problem with a variable on the bottom, you should immediately think about what values can't the solution be. We'll get to some problems like that so you can see what I'm talking about. Our first one does not have that because we don't have any variables in the denominator. Now, like I said, we're going to build up to clearing out fractions. That's our goal today. Is the big thing we're going to talk about is clearing out fractions. Clearing out fractions means we need to find something called the lowest common denominator. In other words, we're trying to multiply both sides by a number that will clear out the denominator or clear out our fractions. We're looking for a number that 2 and 4 both go into. There is a method that works every single time, and that is to multiply every denominator you see together. So you could look at this and go 2 times 4 is 8. That is what we'd call a common denominator. It's not the lowest one, but it will work. I can multiply both sides by 8 and it will clear the fractions. What would probably be a better number than 8? 8 would work, but what would be better, Mira? Just 4. Be careful when you multiply and to use parentheses, making sure that that 4 distributes to both. So we'll notice 2 goes into 4 and 4 also goes into 4. So I'm going to multiply both sides by 4. Correct me if I'm wrong, but I believe I moved this over to the center for you guys so you can have more room to write on each side. Is that correct? Yes. All right, let's distribute it carefully. So 4 times 1/2 equals 2. So we have 2x. Minus 4 times 6 is 12 plus 12, which is 24. Then we have 4 times 3 over 4, which is just 3 because the 4's cancel out. Then we have 4 times 9, which is 36. Now we're just going to go ahead and simplify. However you want to simplify is awesome. You can move that 3x to this side. I'm going to move the 2x so I can keep everything positive. So I'm going to go ahead and I'm going to subtract 2x from both sides, minus 2x. While I'm doing that, I'm going to go ahead and I'm going to add 36 to both sides. So plus 36 will cancel that out. Plus 36 there will leave me with 12. I have x equals 12. If I was asked to categorize that, I would say it's conditional. That is conditional. So just be careful in the directions. I didn't put on there that we had to, but just go that extra step. Let's go ahead and call that conditional. All right, our next one. Well, we don't quite have the luxury of having 2's and 4's, where I can say, well, if I multiply everything by 4, everything's going to cancel out because I have that x in the denominator. First of all, what value of x can't this be, Jake? It can't be 1. So if our solution ends up being 1, we're going to put, oh, it's inconsistent. My solution doesn't work. The one solution that could work doesn't work. So we're watching out to make sure that that's not a 1. So we could put next to it if we wanted to that x can't be 1. Well, this is where we come across that trick that if you're ever trying to come up with an lowest common denominator, and it's not something easy like 2's and 4's, just multiply by your denominators. And I wouldn't distribute unless I have to. So I'm going to say my lowest common denominator is going to be 2 and x minus 1. That way when I multiply this, there's always going to be something for that denominator to cancel out with. Just be careful. Make sure you're doing it to both sides. And you're doing parenthesis. Oh, I thought there's just a mass exodus happening here. So we are going to multiply both sides by that 2 times that x minus 1. So I have 2x minus 1 times that 1. Multiply this side by 2x minus 1. Now, obviously, when I multiply this left side by that 2 times x minus 1, I can go ahead and distribute now. That's 2x minus 2 equals. Now, you can write all this out, but it's easier if we just kind of picture what's going on here. So I have 1 times 2 times the quantity x minus 1. So in this fraction, our 2's are going to cancel out. This 2 and that 2 will cancel out, leaving that x minus 1 in its place. So we're going to have x minus 1 left over, plus, once again, when we move here, I have 2x minus 1 over x minus 1. Your x minus 1's will cancel out. That was the whole point in it, that multiplication allows them to cancel out. So I'm just left with a 2. Then we work our way down. We have 2x minus 2 equals x minus 2 plus 1 is going to be plus 1. Let's add 2 to both sides. And then I'm going to subtract that x from both sides. And we should be left with x equals 3. What number couldn't x be? 1. Did we get out 1? Nope. 3 works. If I plug in 3, I have 1 over 2. That's fine. 1/2 plus 1/2 equals 1. That works. That means this is conditional. Conditional. The next one shouldn't seem hard, and it's not a hard problem. It's just one that is commonly mistaken on tests and stuff like that. It's just lots of little steps that trip people up because they want to go as fast as possible. So this one, we need to take a breath and make sure we do things correctly. Primarily, our first distributing shouldn't be that hard. We're just distributing that 3. So we're going to have 3x minus 3. The big mistake people are going to make is that 2x. It is actually a negative 2x. That negative will be distributed to both items. So it's a negative 2x times 4, which would give me a negative 8x, but it is also a negative 2x times a negative x. Negative times a negative gives me a positive. X times x is x squared, so we have a positive 2x squared. The other side, you might have tricks to solving these. I'm telling you, yeah, we can do FOIL. We can do first, outside, inside, last. Here's how I always tackle it, because it works for binomials, trinomials, fourth power items. And that is just picturing that first term distributing to everything that's there. So if I had a third term, I would draw a third arrow. If I had a fourth thing, I would draw a fourth arrow. Just make sure that first thing gets distributed to all the items in that next parenthesis group.
That isn't FOIL.
What was that?
That isn't FOIL.
That is FOIL.
Oh.
So FOIL is firsts, but then they have outside, inside, and then they do lasts. I just like to picture it as I'm just distributing the first thing, I'm distributing the second thing. I don't like fancy words because FOIL only works if it's a binomial times a binomial. And if you don't understand that this should work for a trinomial, then it's kind of a useless thing to remember. I just remember distribute this, and then we're going to distribute the 1. So we have 2x times x, which will give us 2x squared. I have 2x times a negative 3, which is a negative 6x. Now I switch to the next term and distribute that the same way. I distribute to the x and the 3, so I have 1x minus 3. Let's collect like terms. Let's rearrange stuff so our highest power is out front. So I'm going to notice we have a 3x. And we have a negative 8x. Maybe I'll circle that because it does have a negative. I'm also going to push the 2x squared out front. So we have 2x squared out front. I'm going to have negative 5x. I'm going to have a negative 3. The other side, we are going to note that we do have a negative 6x and a positive 1x, which will give me a negative 5x minus 5x minus 3. At this stage, you're actually done. You can, right now, yeah, it's dependent. So at this stage, we can put it is dependent, and that's as far as I need you to go. It is dependent, and that's as far as you need to go. Let's say you didn't realize it was dependent there. Maybe you didn't rearrange this so the powers matched up, and you're like, well, I'm in this mode where I'm just going to solve stuff. Well, maybe you subtract 2x squared from both sides, and then you add 5x from both sides. So if you just continue to solve this, you would at the very end with negative 3 equals negative 3. At that stage, you would go, okay, that's a true statement, which would lead you to say it's dependent. Both ways are perfectly acceptable. On the test, if you'd stop at this stage and go, it's dependent, cool. If you solved it all the way, came up with a true statement and put it's dependent, cool. You both have dependent as your answer, so both work. All right, questions on those? Like I said, hopefully this is mostly just review. I hope. All right, our next one. What would I multiply both sides by if I wanted to clear those fractions? In fact, because we got to clear those fractions, we have to get a variable on the top. Yeah. We're going to do not y plus 3. We're just going to stick with the y minus 3. Plus 3 would be if I wanted to, typically those are if I want to get rid of that y or something. That's if I want to move like a square root to the top. That's when we multiply by that. But what I want to do is I just want to clearly clear out those fractions. So we're going to set our LCD to just being y minus 3 because I just need them to cancel. I don't need to manipulate stuff. I just need it to cancel. So if I multiply that left side by y minus 3, you may want to put it y minus 3 over 1 if that helps you. Other side, we'll do y minus 3 over 1. You don't need the 1. We could just leave it as y minus 3. Just some people with multiplication like doing that. Well, if we kind of go through this, we're going to see our y minus 3's cancel out. And I'm just left with y plus 3 on the left side. And on the other side, my y minus 3's cancel out, and I'm left with 3. And there's a big mistake there. Yeah, babe.
Would it be 3y minus
would it be 3y minus 9?
Plus y, sorry. On the left side.
On the left side, say that again?
Y plus 3y minus 9.
Yes, yep. So I didn't distribute it. I haven't distributed it yet. So we have to multiply by that 3. So we do have more to do to that left side. So we should have put parentheses. We should have had parentheses here going, okay, that y minus 3 must distribute to both items. Yes, I agree that y minus 3 over y minus 3 cancel out, so I'm just left with a y here. So when I distribute this here, cancels, I'm left with the y, but I do still have to do, like Peyton said, I have to multiply that by 3. I'm going to do the long way where I actually write 3 times y minus 3. That's going to equal my y minus 3, and that y minus 3 cancel out. I'm just left with 3 on the other side. Peyton had already distributed this, so we have y plus 3y minus 9 equals 3. Let's keep going. So I would have 4y. Add 9 to both sides, and that equals 12. I have y equals 3. I circle it, and I put conditional. And I lose a point on the test. Everyone look at that. What's wrong with it? What did I do wrong? Carolyn?
Like if you go check it, you have to do it's 3 minus 3, so it'd be an extraneous solution.
Yeah, what's the one number the answer can't be? 3. If I go back up there, I say everything can be a solution, but y cannot equal 3. Because just like Carolyn said, if you plug it in, you can't. You get a 3 over 0. You have a 3 over 0 plus 3. That doesn't work, so it can't be conditional. And like I said, if you were to check this, and you were to plug in, so if we would say, okay, let's let y equal 3, then we would have we'd have 3 over 3 minus 3 plus 3 equals 3 over 3 minus 3. Both of these are undefined. So rather than being conditional, this would be inconsistent. It would be inconsistent. There is no solution. So that's why my ultimate advice is, if you see fractions and you see a variable in the denominator, you should start off by going, this one won't work. 3 will not work. So your first thing you should have thought of is, what value can't y be? It's 3. You come up with 3 and you're like, nope, doesn't work then. No solutions, it's inconsistent. Because this gave you one possible answer and you already said that answer won't work. So there are no solutions to this. All right, our next one. We have 2 over x squared minus 1 equals 1 over x minus y minus 1 over x plus 1. Now, I said one of the tricks is to multiply all your denominators together. So one method you could do, you could have x squared minus 1 times x minus 1 times x plus 1. That is not the simplest way to handle this one. Tali, what's the easier thing to multiply on both sides?
Well, the 2 bottom denominators multiplied is the other denominator.
Equals that one, yeah. Oh, yeah, these two things are equal to this, so it doesn't pay to multiply this in there. Our lowest common denominator is just going to be that x minus 1 times that x plus 1. And in fact, I'm going to write both versions of it. So our lowest common denominator will be x minus 1 times x plus 1, because that's the exact same thing as x squared minus 1. Now, here's some advice for this type of problem. We know we're multiplying by x squared minus 1. But when I multiply x squared minus 1 on the right side, I'm going to use this form so I can see what cancels out as we go along. So it'll look like I'm multiplying by 2 different things, but I'm multiplying by 2 things that are equal to each other. And maybe I should write that before I just keep spewing about it. So we're going to multiply the left side by the version of it that's x minus 1 times x plus 1. It's going to be easier to visualize what cancels out. The left side, I'm going to multiply by that x squared minus 1. We said the two things are equal to each other, so I can pick whichever version I want. And on the left side, it's much easier to picture your x squared minus 1s canceling out and just leave me with 2. Then when we get to the next thing, if we kind of picture up here, I have an x minus 1, x plus 1 on top, and on the bottom I have an x minus 1. Your x minus 1s will cancel out in this first one, leaving behind that x plus 1 in its place. Minus. Once again, picture that x minus 1, x plus 1 on top of this x plus 1. Your x plus 1s will cancel out, leaving that x minus 1 in its place. Now, note my parenthesis usage. It's imperative that we pay attention to parentheses when we have negative signs. It'll be the difference between this one being a dependent or an inconsistent. Because as we go down, we're going to have 2 equals x plus 1 minus x plus 1. If you came up with 2 equals 0, that is incorrect. That would be inconsistent. Instead, we should have x minus x, which is 0. 2, we end up with 2 equaling 2. That would be dependent or an identity. All right, the very last thing. Yeah, go ahead. Yes, so it would be probably a little clearer if we said that. So it is dependent. Dependent already has it clarified. It has to work for it. So it's all numbers that work in the system. So you could clarify and you could be like, well, x cannot be positive or negative 1. You could add that if you wanted to. Dependent as it is, notice how it's the word dependent. I didn't put all solutions. I put dependent. Dependent is any number that doesn't break it will work. So that has a little clause in it that says it shouldn't be positive 1. But I am going to go back and say, I like that you thought about that because that should have been the first thought you had, that x cannot be 1 or negative 1. And it probably would have been a good idea to, if not think it, even write it right at that first stage. That right away we just go x can't be 1 or negative 1. If you get in the habit of doing that, on the test you're going to catch the couple that I do make where it doesn't work because of that denominator. So if you're doing that check and you write it down right off the bat, then you don't have to worry about it. All right, the last thing we're talking about is absolute values. We start with the easier absolute values and we move to harder problems of it. Absolute values on their surface aren't so bad. We've worked with them before. Just remember, an absolute value is your distance from 0. Distance is positive. That's why whenever you take an absolute value of a number, it turns it to its positive version. Which leads us to some unique solutions when you have absolute values. First of all, if you take an absolute value of a number and it equals k, and k is a positive number, consider k 2 in this case. You actually have 2 possible x values. X could be 2, because the absolute value of 2 is 2. And it can also be negative 2, because the absolute value of negative 2 also equals a positive 2. So if you have absolute value all by itself and it equals a positive number, you have 2 solutions you need to look for. If you have an absolute value equaling a 0, you just have one solution, that x must equal 0. There's no such thing as a positive 0 and a negative 0. It's just 0. Also, be on the look on this third case. This third case is, what if I have an absolute value, and I say absolute value of a number equals a negative number? By definition, you can't take the absolute value of a number and it results as a negative number. In this case, you have no solutions. But before you just start writing no solutions on things, make sure that this is isolated first. Before you look at absolute values, you have to make sure it's isolated, it's all by itself before you worry about whether there's solutions or not. So in our first example, it is already isolated. Isolated means that all you have is an absolute value on the left-hand side, and you have a number on the right-hand side. That number is a positive 4, which means we're going to have two solutions. Either what's in here is a positive 4, or what's in here is a negative 4. Absolute value of 4 is 4. Absolute value of negative 4 is also 4. So we're going to set this up as two separate equations. We're going to say either what's inside the absolute value bar equals 4, or what's inside those absolute value bars equals a negative 4. Well, if x minus 5 happens to equal a positive 4, that means that x would have had to equal 9 to start off with. In order for x minus 5 to equal a negative 4, x would have had to equal 1. And then if you plug those in, it should work. 9 minus 5 is 4. Absolute value of 4 is 4. 1 minus 5 is negative 4. Absolute value of negative 4 is 4. Our next one, I did speak upon this before. It has to be isolated before you do any work. Do not just go, oh, that must mean x plus 8 equals 0. That's not what's happening here. You can't split it apart until it's isolated. So you have to go backwards, and I'm going to circle this, and I'm going to say we need to get that alone or isolate it. So treat it as just a variable for a second. Treat it as 2x minus 6, where you have to get x by itself. Well, so if I need to get that by itself, the first thing you're going to do is you're going to add 6 to both sides. That'll get that 6 to the other side, which will give me 2 times that quantity, x plus 8, absolute value style. And then, even though it's an absolute value, you can treat it as just like a regular variable where I divide. I'm going to divide both sides by 2 to get x plus 8, absolute value style, all by itself. Now it's isolated. Now we can decide if there's a solution. We know there's going to be two solutions because this is a positive 3. So we're going to split it apart into either the inside equals a positive 3 or that inside equals a negative 3. This would be subtracting 3, so x could be a negative 5, or x could equal a negative 11. Don't forget about this lesson. I think a lot of us are looking at this and like, I've seen this before. Don't forget about it. It will be on the test. And consistently, a whole bunch of people get these problems wrong because they don't go back, they don't study it, they don't look up inconsistent, they don't understand that fractions create paradoxes where you get a solution, but it's actually erroneous, that if you plug it back in, it's inconsistent. So go back to this lesson when you're studying to make sure you understand these basic questions, get these right on the test.